Good morning, ladies and gentlemen. Welcome to the Past Virtualization virtual chapter meeting for the month of November. We have Michael Corey here. He's going to be talking to us about how to do Monster VMs correctly for SQL Server. I appreciate Michael taking the time out of his schedule today to teach us about this. And Michael, I'll turn it on over to you at this time.
Perfect. First of all, I want to thank everybody for taking the time to attend this webinar. I know we all have very busy lives, so I'll get on with it. Just to set some expectations, I'm going to go through a lot of material, about 137 slides. Hold on. Okay. This is a slide that I just put up about myself just because I think it's helpful if you get a little bit of background. I've been very active in the database community for over 30 years. I'm a past president in International Oracle Users Group. I actually helped get in a room and found the Professional Association of SQL Server. I've written numerous books, though more on the Oracle side than the SQL Server side. I'm currently president of the VMware Special Interest Group focused on Oracle. I'm also a recognized Oracle ACE, a recognized VMware vExpert, and a recognized Microsoft Most Valuable Professional. I have opinions. I don't claim to be right on everything, but I'll at least tell you what I'm thinking and why. I'm also going to hold questions off till the end, just so I can get through the material, and the presentation will get progressively more technical as we go along. This particular presentation was given at VMworld, both in Europe and in the US, to a couple thousand people, well over actually at this point, 3,000 people, made top 10, and I co-presented with David Klee, who I know is a regular on this webinar series and a wonderful resource. And in fact, David is one of the people I've been collaborating with for a lot of years, and so I highly recommend that you look at his website. I am an author. I will give a shameless plug. Take it for what it is. I make probably 10 cents a book, so if enough of you people actually buy a book, I can afford a cup of coffee. But the book is an excellent resource if you are attempting to virtualize SQL Server on VMware, and actually we'll be collaborating with David on the next version of the book. I'm going to do something a little different here, in that I'm going to do both Oracle and Microsoft SQL Server, because a database is a classic Monster VM by definition. I used to maintain two separate decks, and what I realized was that the issues we all face are the same. And so I at one point just consolidated the deck and put some highlights from both databases into it. But the things that work in Oracle work in SQL Server primarily, and the things that work in SQL Server really apply to Oracle and apply to any Monster VM. A lot of the material for this presentation comes out of the database workshops that I help run with VMware. This is a picture of a SQL Server workshop. I'm actually flying to Bulgaria on Thursday, where we're flying in a lot of people from Europe and Africa to attend the next iteration of this workshop series. And what you'll see is, I'm sure some of you will recognize some of the faces in this picture, but a lot of this material is a direct result of my participation in these workshops and hearing from some of the experts that actually wrote the code. And in fact, in Bulgaria, I'll be joined by Mr. Cherry, Mr. Klee will be joining me, Mr. SQL HA. This is a picture on the Oracle side for anybody that's on the Oracle community. Once again, a lot of this material comes from both of these. So the first question I always like to set up level base is, what is a Monster VM? And interesting enough, that in 2011, vSphere started to get serious about really big, complex virtual machines. And that's when this term really started to originate. And it was defined as a virtual machine with more than 255 gigabyte of virtual RAM. Now, interesting enough that vSphere 6, and actually 6.5 just came out, raised the bar to 128 virtual CPUs and 4 terabyte of virtual RAM per VM, and actually that number's been juiced way up. when I first started doing this presentation, or the earlier iterations of it, I used to get people who used to think the database was too big to virtualize. And in fact, I would then put this up, and I would say to them, is your database bigger than 75 application tiers? Is it bigger than an 8 terabyte database? Does it have more than 8.8 billion rows? Does it do more than 52 million transactions per day? Is it handling almost 80,000 IOPS? Does it have 40,000 named users? Does it have 4,000 peak concurrent users? Because if it's smaller than this, it can easily be virtualized. And in fact, this was done before vSphere 6. This was done in version 4. And everything about this application, which is an Oracle E-Business Suite, which for those of you who don't know is a very big, complex application, worked great. And in fact, everything about this application got better. Now, in the deck slides that I no longer include, one of the key reasons is that it was run on new hardware that had all the special chips that enable virtualization. But the point, which I think is 2 points that come out of this is, A, I'm focused on VMware, so vSphere for this presentation, is this was done 2 versions, actually 2.5, 3 versions ago, and everything about it got better, and today vSphere is able to handle bigger and bigger, more complex virtual machines. So this is old news. And in fact, this is a vSphere 6, and what you see is 128 virtual CPUs, 4 terabyte, and to use the words of Mr. Klee, if you can't virtualize it in that, he wants to hear from you. So David will be very excited if you have something that's bigger than this footprint that you think you can't virtualize. And in fact, you'll notice that vSphere did a 4x scale improvement from the previous version. I'm always amazed at how many people have never heard of Project Capstone. And Project Capstone came out in 2015 in VMworld. And what was really interesting about Project Capstone was what they did was they attempted to take the biggest VM they could think of, put in the biggest, baddest HP Superdome X on a flash storage array, and they attempted to run it through a huge benchmark and see what happens. And in fact, they used, you can go out to GitHub, they have the DVD store, which is available to anyone, which basically simulates online ordering of DVDs. And what they did was they basically crunched it through this box and saw what happened. So the benchmark for performance was orders per minute, with each order representing a login, browsing, purchasing, with lots of SQL operations against the database. All 480 threads on the server were near saturated during each configuration test. And in fact, you can use this benchmark yourself. It's readily available. Mr. Klee has a great guide on how to do this if you want to go back in your own lab and see what happens. In fact, at this expert workshop that I'm going to in Bulgaria, one of the things that's really nice is that you get all these key people who are going to actually be able to beat the crap out of VMware themselves and see what they can see how it performs firsthand. And so for those people in the US, when I was a kid, we had a Gumby, and to me, that's the perfect mascot for Project Capstone because it stretches the limits. So a couple of things. For Project Capstone, they use an Oracle 12c database. They used Linux. I know you're a SQL Server gang, but I just wanted to find what they use for the benchmarks. What's really interesting is that they use 2 VMX Net3 NICs, and they used a Paravirtual SCSI disk adapter, which I am going to talk about more later. And they use this thing called Preferred HT, and I am going to talk about that a little later. I'm not telling you to go run out and use Preferred HT. What I'm telling you is this is what they did for purposes of the benchmark. So Preferred HT is really interesting because what it does is it says you'd rather have access to the processor cache and NUMA memory locality as a priority over the additional compute cycles. What I would walk away from with this is just how important NUMA is. NUMA, I'm going to quote Mr. Klee, is one of those things that by adjusting it, he's seen greater than a 40% improvement in performance. So the idea here was really focusing on NUMA memory or NUMA locality over the additional compute cycles. And that's what Preferred HT did for them. So, and what we'll do is we will discuss NUMA in some great detail later, and there's some great resources on NUMA available too. And what the point of this slide is to show you that it's scaled, 92% of linear, that as they went bigger and badder, the technology, vSphere, scaled, right? 20,000 IOPS, 0.3 ms milliseconds response time, a peak of 50,000 IOPS, 60 cores, 120 threads. I mean, this is a big, bad VM. And they did different iterations in different sizes. And what you see is it keeps scaling, 89% of linear, 15 cores, 30 threads. So it's interesting that the bigger the VM, the better it seemed to scale, just ever slightly. The other thing you should walk away is that to get this CPU usage so high, the I/O had to be incredibly fast, so the system was never waiting for a response. In other words, that was the importance of the flash array, right? So they could drive CPU way up. And I apologize, I know we're going through. And so the point being, vSphere is ready for every application, every database, and I would argue today is a candidate for virtualized infrastructure, and I'll define that as 98, 99% of the world can be virtualized today if done properly. And interesting enough, the SQL Server crew is way ahead of the Oracle side of the house in terms of virtualization. You as a community adopted this so much quicker, and we'll talk about that a little bit. And what does VMware mean by any application? This is a classic VMware slide. Scale up, scale out, everything in between. SAP HANA, Exchange, SQL Server, Oracle, MongoDB. And so I've got the picture of the Monster VM, burp, just taking it in. No application left behind. I think it's a very strong statement. So this is a really interesting slide, and in fact, what I really like and what it shows, I'm very pro SQL Server, is that Microsoft SQL Server has the greatest adoption, well over your Oracle counterparts. Is about, well, 2015. I know there's a new survey that's about to come out. It comes out of Database Trends and Applications magazine, which is a free magazine. I encourage you to subscribe to it. I also write for the Big Data Quarterly. I also encourage you to subscribe to that. We do a lot of interesting write-ups on databases. And I use the picture of M&Ms to basically say, once you embrace virtualization, it's like M&Ms. You keep going back and doing more and more and more of it. This is the IOUG. This is the Independent Oracle Users Group, the Empowered Database Survey. A lot of their members also support SQL Server. And what you see is that 50% of this membership, which is a pretty large sample set of people, prefer vSphere over everything else. They prefer it over Oracle VM. They prefer it over HyperV. If I were to stack hypervisors, vSphere comes out at #1 in my opinion, and I'll tell you why. And then HyperV comes out at #2 in my opinion. Those are the two platforms that I would focus on. And in fact, I would argue that today, VMware is the big dog, right? And Hyper-V is still playing catch-up. Just the ease of being able to do things in vSphere just makes it a no-brainer, but you have to weigh that against the cost. But Hyper-V is certainly a credible hypervisor. And so to me, the new norm, I'm a guy from Boston. If you haven't picked up, I haven't said chowder and lobster yet. I'm a guy from Boston. The new norm is you should be virtualizing, right? Make mine a VCDX Special Air. So VCDX is the doctorate of virtualization in terms of certifications. That's the way to think about it. And just as a side note, I actually met Norm one time. I walked into a bar, and sitting at the corner of the bar in Florida was Norm. So being a guy from Boston, I said, "Hi, Norm." Mr. Weatherall was not too happy with me. He wasn't happy about me saying hi, Norm, which I think is kind of ironic, given that he was sitting at the corner of a bar, of all places to sit. This report, from a Microsoft perspective, you guys and gals should absolutely love. Gartner said for the first time on operational databases that Microsoft is #1. And there's good reason for this. Since 2005, you've had a hell of a database package. That's when I really felt it was ready for prime time, and it just keeps getting better and better. But when you look at the entire toolkit, it's an awesome platform, which you all know, for running your business on. And in fact, Gartner acknowledged that. And so I look at Oracle looking up at SQL Server. Houston, we have a problem. And that was as of 2015. So why do you virtualize? These are reference slides. I won't spend a lot of time. But basically, if you're trying to make the business case, it's really about reducing licensing costs, consolidation of your hardware, being able to provision databases on demand. The high availability features of VMware really help on the database side, but it's not an answer to everything. And the complete isolation between the hosts. If you're trying to convince management to virtualize, go back, do a little Google search, and these things will get you in the right direction. So I say winner, winner, chicken dinner. To me, the real reason you virtualize is because of the consolidation, which saves you a lot of money. And by the way, we see typically 60% reduction in CapEx. If done correctly, this can save a company a lot of money. So show me the money. That is the reason to be virtualizing, especially when the industry, if your industry is facing tough times, this is one of those technologies that can really help save on the bottom line and yet improve database availability. How many people had the privilege of getting the new blue screen of death? Well, I'm on a Mac, but this point really illustrates something really important. And I want you to think about what's the #1 reason you get the blue screen. And the answer, we'll give it a second, drivers. In the physical world, no vendor can possibly vet all the drivers, all the permutations possible. And new drivers are the #1 reason that you would get the blue screen. In a virtualized world, you have a concise set of drivers that are well focused, and it is possible to vet them. You are less likely to see the blue screen. And my favorite on this is bad drivers. We all know one. So, but that's the #1 reason that you see the blue screen. So this is really kind of a reference slide. There's some great technologies with virtualization, and there's some downfalls to that, like the ability, especially in an Oracle environment, to adding memory. But the point I want to make here is utilizing CPU hot plug disables vNUMA, and if you walk in with anything, walk in with, dude, no, bad idea. NUMA is just too important. You do not want to disable it. So the benefits of CPU hot plug are not worth it when you lose NUMA. Remember, I quoted Mr. Klee, greater than 40% improvement by tweaking NUMA. For those people that are on the Oracle side, in order for you to use hot add memory, since the database is not linked to the operating system the way a SQL Server database is, you would have to bloat the SGA, that's the system global area, so that when you added the memory, the SGA was able to take advantage of it. Well, the problem is you're in a shared resource environment, and if you bloat the VMs, of which the database sits on, then you are hurting performance of yourself, and you're hurting performance of the database. This is a really bad idea. And if you're going to virtualize a Monster VM, you're going to virtualize a SQL Server database, which by definition many times is a Monster VM, you need to right-size the VMs. You need to right-size the databases. You're in a shared resource environment. And even if you're in a standalone, bloating of a VM hurts performance of everybody, including yourself. So in the physical world, that's probably not the case, but in the virtual world, that's absolutely the case. And so if you walk away with a really important lesson here, what I would say to you is right size, right size, right size. Right sizing improves the size of the VM or minimizes it, which increases the likelihood that you fit in a NUMA node, which means you get the benefits of NUMA, and we will talk about that in a lot more detail. Let's talk about the hypervisor. So this is an old slide, and we talk about virtualization having less than a 5% overhead as compared to native. And what I used to hear from arguments, and I still do, is that native is more leaner and meaner, and I need that for my database, and that's a bunch of crap. Because frankly, if you don't have at least 5% headwind in your systems, you're hosed. Let's repeat that. You are absolutely hosed. Any system that is so busy that there's no headroom, then you've got the system competing for resources on itself. That's bad. So I will acknowledge that the physical world is slightly more efficient, but in the newer versions of vSphere, we're talking about a 2% overhead. In fact, David were on this call. He's at the MVP Summit. I didn't make it this year. If David were on this call, he would tell you it's less than 2%. So this hypervisor is lean and mean. And if you think about a hypervisor, how is it different from an operating system? It's different from an operating system in that a hypervisor has to manage multiple operating systems. That's the fundamental difference. So for all intents and purposes, a hypervisor is a lean, mean operating system that also manages other operating systems. So under a hypervisor, you could have Linux, you could have Mac OS, you could have Windows OS. That's the core difference. But we are talking about a very lean, mean hypervisor with less than 2% overhead. This is the reason why I prefer vSphere over all other hypervisors. So first thing I want to make a point, I think this is really important, and I'm going to say it in a couple of ways because I think it is so darn important. It provides 100% abstraction between the operating system and the hardware. When you use vSphere as a hypervisor, and this is not true for all other hypervisors, it does not change the OS stack in any way. What I mean by that is the operating system you are working on is the same operating system you work on without any changes in the virtualized world, because there is 100% abstraction, which means that you are not going to see bugs in how your database operates because of the hypervisor. Now, if you use a hypervisor that changes the operating system, it then becomes more likely that you might see a bug that shows up when the database is virtualized that you would never see in the physical world. Now, what I really like about this test is that it was done in 2013, where basically they took an Oracle RAC database, and for those of you that aren't familiar with Oracle RAC is active-active. So node A, node B, and node C, all updating the database at the same time. So every one of the nodes is a reader, and every one of the nodes is a writer. And then what they did is they decided to do a vMotion. So vMotion is when you take a virtual machine and you ask it to move while people are using it in this scenario. So they told node A to go to node B. They told instance B that's on node B to go to node C, and instance C that's running the version of the database to go to node A. And they did this while it was under an incredibly heavy load. And then they did this with an Oracle RAC database, which is active-active. And nothing broke. Then they did this, they created 3 more databases, and then 3 more. So you had 9 separate databases running in sets of 3 that started merry-go-rounding and nothing broke. I don't know of another hypervisor that's run this test or another hypervisor that could actually do this. That's a real tribute to the stability. And vMotion has been around a long time. It's over 10-year-old technology for VMware. So I want to talk about service level agreements in the DBA. Had a situation where a company monitored critical medical equipment that was keeping people alive. It was a SQL Server database, and they were only able to use 50% of the available memory on the CPU. We troubleshot the problem, and what we realized was they had a BIOS setting that needed to be adjusted, that was artificially slowing down the CPU. Every time we talked to the customer about rebooting the system, there was never a good time to take the system down. So then I got involved and I looked at the system. They had a standalone SQL Server database on direct attached storage that wasn't even RAID. And I thought to myself, my God, they are under this impression, the users, the community, that the system is fault tolerant and will never go down, but the physical infrastructure doesn't support that. This is an absolute problem. And in fact, I had to go back to the customer and I had to explain to them that they had a real problem. And what it does is it illustrates a whole bunch of things. First of all, had it been virtualized, there would have been more options for the DBA. Second thing is they had an elephant in this room, and I'm going to talk about this because I think we can learn some lessons from this in a slide or two. But imagine the user community thinking the database would never go down, and yet you as a DBA know that it sits on a standalone database instance with direct attached storage that wasn't even redundant. You got a real misconception of database availability to reality. And so the bigger issue is management expectations concerning the availability of the database, Monster VM, and the physical infrastructure are out of sync. And as a DBA, you really need to go have that conversation. You need to say to management, look, if you want the system never to go down, then I need to get the following equipment. I need a RAID box, I'd like to virtualize the database, whatever you define that is. And I can guarantee the system will probably never go down. And it's going to cost you $500,000 and management chokes. So then you say to management, well, if you don't give me the equipment I need and the technology I need, guess what? I can't guarantee the system will never go down. You've done a CYA, but more importantly, you've reset management expectations. And really, that's one of the things we need to do. And there's a good chance that if you present it correctly and the business really needs to never go down, you might actually get the technology you need to pull it off. So I really think that as DBAs that are in the audience, we can learn from this. And I just love this picture of the baby. And so I go back to you and say, if you had an unplanned outage of 3 days in a row, would your users be happy? Technically, you had 99% availability. You met your SLA. But the point is, your goal was achieved. No, your goal was not achieved. Nobody would be happy with this. So David and I both agree that you have to really, if you decide to virtualize your database, you have to understand that in order to do it properly, VMware HA is great technology, but it does not help with planned outages, maintenance. It's only half the answer to your problem. Like the ability to vMotion is great, but you also want to be able to do a point-in-time recovery, and that means that the DBAs have to work with the VMware HA administrators to figure out how it all works so that the customer is completely planned. But what's clear is VMware only solves half the problem today. And so once again, I go back to that point. You got to reset the expectations, the elephants in the room, or you're not doing your company any justice. And oh, by the way, if you don't get the resources you need, you've reset the expectations, you've covered your rear end. And so the other lesson to be learned about this is you've got to pay attention to these BIOS settings, right? Because there are things like green settings that are energy saving that could affect the performance of the chips, which is what was happening in this particular scenario. And so physical hardware limits affect the virtual environment. If you only have 32 gig in the system, even though you can overcommit memory, you still only get 32 gig at one point. If your power management is set to energy conserve, it can affect things like your PCI slots and flash storage and your HBAs. You want to make sure that you don't artificially hold back your hardware. And in fact, there's a great paper that helps you with things like this. Right? So physical resources, there's 2 slides in this, really affect and become hard limits. And in fact, there's a nice tool, CPU-Z, that will help you look at profiling your Microsoft Windows environment. If you haven't used it, it's free, and it brings a lot of useful information. Okay, let's talk about how to do it right. So you're getting ready to virtualize a Monster VM, you're getting ready to virtualize a production database. First thing I've learned is that the lessons learned in the early days of virtualization don't always apply when you actually put a production database for a Monster VM in, because most of the early systems are built on capacity, not performance. And a Monster VM eats what I call the IT food groups: CPU, disk, memory, and network. So I love that. Monster VM saying, I eat CPU, disk, memory, and network for breakfast, lunch, dinner, and dessert. So let's talk about the path to database virtualization. First of all, read the documentation. I know it sounds trivial, but if David were here, I always joke and say, how many clicks does it take to install VMware? And Dave always knows the exact answer. But the point is, you just throw VMware in, you hit return, return, return. I don't think it's like 32 times, and it installs itself. It's the easiest install you'll ever do. If you're not going to read all the documentation, at least read the storage vendor documentation, because the majority of your problems, and we're going to give you some percentages later, happen with the storage array being misused, misaligned, or missized. So if you don't have time to read it all, then read the storage vendor. VMware does a great job on blogs. So this is a great place, blogs.vmware.com, with lots of useful information. In fact, there's an Oracle paper that got published. The VMware SIG, which I'm recently helped found about a year or 2 ago. You're lucky on the SQL Server side that you don't have all the licensing issues they have on the Oracle side. But we ran a seminar with Mr. Welch, who's the licensing guru. And he answers questions about SQL Server and Oracle. PASS. I mean, the fact that you're here, you understand PASS. Every time I go to VMware, I ask, so when this presentation gets given, we have about 1,000 people in the room, and usually less than 50 people or 100 people have heard of SQL Saturdays or PASS. So spread the word. It's a great resource. My hands go off, my hat goes off to Tom and how he runs this virtualization SIG and brings in people like Mr. Klee on a regular basis. You're very lucky to have such a committed person putting on events like this for you. And it's a lot of work. I've done it myself. This SIG, I like to tell the world about this SIG and the fact that he covers Hyper-V and vSphere. My blog, I've got some great resources. This particular one highlights an Oracle resource on licensing, but I have lots of resources on the SQL Server side. Hera Flex, that's Mr. Klee's site. That's his company. He writes lots of useful utilities that are out there for you to go. David is a tremendous resource. Recently moved to Maine about a year ago. So he's a local resource for me out of Boston. Long White Clouds is an incredibly useful site. Michael Webster is one of my co-authors on the first iteration of the book on how to virtualize SQL Server. He puts lots of great things. He works for Nutanix, and now he does lots of great write-ups on hyper-converged infrastructure. But you'll find lots of things on the SQL Server side from Michael. I think he gets like 30 or 50,000 visitors a month and gets rated as one of the top virtualization blogs. If you've never heard of it, he's out of New Zealand. For the Oracle people, if there are, this is the new location for the blog specifically on Oracle and papers. For the SQL Server side, this is the new location. It kills me when vendors like VMware move a location and they don't remap it so that we don't have broken links. And you'll see some great resources and some great blogs and some great white papers. And in fact, later on, I'll highlight a couple that I think are particularly good, that David and I both agree are particularly good. And these are reference slides, and this deck will be available. And there's a version of this deck that's available on michaelcorey.com now if you don't want to wait. So here's a performance characterization of Microsoft SQL Server on VMware v3.6. That's a great PDF. It's a great resource. On the Oracle side, there's a paper that talks about defining CPU affinity feature. Now, this is something that's really important, I think, even on the SQL Server side. What VMware will allow you to do today is they will allow you to pin the CPU. So if you're in a hyperconverged infrastructure with 32 CPUs, you could pin it to the first 16 and make an argument to the vendor that you've never gone beyond the first 16 and should only pay for half the CPUs on the box. This becomes critical depending on how you license. Now with Microsoft, you have some obviously other options. And they're a little easier to deal with in this issue, but it's useful to know CPU affinity. It can save a company a lot of money. Now you're going to virtualize a Monster VM. You got to start off with the installation and having a plan. And David and I both agree on this: baseline, 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 baseline. And I'll give you a perfect example. I was dealing with a vendor. They had a brand new system. They moved over the biggest complex application they did onto the new hardware and the new storage array, and everything about it got slower, and they hadn't even worked on everything. They went back to the database vendor. They went back to the vendor that sold them the equipment, and nobody could give them an answer. And I said, $5,000, 2 weeks, I'll give you an answer, and if your kids are ugly, I'll give you an answer that they're ugly. The vendor looked at me and said, how the heck can you answer this question in 2 weeks, $5,000, when the vendors can't seem to answer this question? I said, I've been doing it for 30 years. Yes, I've been doing relational databases for over 30 years, from Sybase to SQL Server to Oracle. And I went in and I baselined. And the first thing I did when I met the gentleman is I said, your kids are ugly. And he goes, what do you mean? I go, your problem is that your new storage array is slower than your old storage array, and a database is an extension of your storage array. Slow storage means slow database, and any DBA worth their weight should have easily been able to figure this out. I thought it was going to be the needle in the haystack like a BIOS setting, and when I got the baseline back, it just threw over. But the point is, if I don't have that baseline, how do I know how it's performing in the new environment? How do I know what resources? We had a hospital in the Boston area that had 2,500 SQL Server databases instances. And they did a P to V, a physical to virtual migration. And all that did for them was everything worked fine, but it bloated all the VMs and caused them to spend way too much money on licensing. So baselining is the most critical thing that you can do. Second thing is understanding your I/O requirements. And third thing is having a licensing strategy if it's needed, and then a backup and recovery strategy that goes beyond just VMware, because there's the database. But the old saying, if you aim at nothing, you will hit it every time. Have an installation plan, especially for Monster VMs. Garbage in, garbage out. If your new virtualized environment hasn't changed from your old physical environment, then why would you expect anything to get better? It's not a silver bullet for all the answers. Garbage in, garbage out. If the old system was slow and nothing's changed on the new system, guess what? The new system's going to be slow. So what are your baseline? Your baseline are the IT food groups: disk, CPU, memory, and storage. And use that as the basis to right-size all the VMs. And we will talk about should you have more VMs, less VMs. We'll get into all that. So this slide talks about the VM choke points. By the way, these are the same choke points you'd have on Hyper-V. These are the same choke points you'd have on Hyper-V. And I use a picture of twins. Why do I have a picture of twins? Because the choke points in the physical world are the same as the choke points in the virtual world. Monster VM choke points look just like normal choke points. CPU, memory, disk, and network. Your problem is going to be in one of those 4 areas. And oh, by the way, you got an 80% likelihood it's going to be at the disk based on VMware support questions. So if you have a problem and you don't know where to look, the first thing I do is I look at the storage configuration, how it's being utilized, how it's laid out, how it's being configured. A good baseline is just so critical. When you base a database or a Monster VM, you want to use really short interval frequency, 15 seconds or less. T-SQL 1 minute or less. Monster VMs, the smaller the sample, the better off you are. A lot of packages that do baseline look every 30 minutes or every hour, and what they do is they smooth out those valleys, which really underestimates the number of licenses you need. Do you think VMware is going to be hurt if you have to come back and buy more licenses after you go down the path? Of course not. So keep in mind, lower is better. And in fact, I've got the picture from Animal House, baseline to the lowest level. If David were here, he'd say by core, if possible, by NUMA node, by drive, by disk controller. He would tell you to get as low as possible. So now we're at the halfway point. I'm running about 10 slides behind, so we're in good shape. I always like to do trivia because I think it breaks it up and gives me some timing. But before I do, and by the way, congratulations to anybody there from Chicago. I was rooting for you, and I was so pleased to see you break that 106 or 108 years. But for those people that have ever been to Fenway Park has Morse code. There's 2 lines of it, and in fact, there's a picture of the green monster, as we say in Boston, and a sample of one of the 2 lines of Morse code, which is the initials of the Yackee family that used to own the Red Sox. And when they renovated the park, they had Morse code put in the green monster. So name the only 2 people in the Baseball Hall of Fame that never played professional baseball, weren't owners, weren't managers. For all intents and purposes, had nothing to do with the sport. They didn't create the sport. The answer is, Who's on First? Abbott and Costello for the famous Who's on First routine. There's a whole section of the Baseball Hall of Fame dedicated to them. It's a wonderful take if you've never gotten upstate New York to see it. And because 2016 was our National Parks 100-year anniversary, I decided to create a National Parks quiz. What are the only moving National Historic Landmarks? And I'll give everybody a second to think on this. There are actually 2 that I know of. National Historic Landmarks that move. The first one is the cable cars. Is a building, site, structure, object, or district that is formally recognized by the United States government for its outstanding historical significance. So on the West Coast, it's the cable cars. Now the question is, what is it on the right coast? It is Old Ironside, the battleship in Boston, which is still an official battleship for the U.S. So back to the presentation. When you're trying to understand the workload, David has a wonderful write-up on how to set up the perfmon collectors. Go to David's write-up. This is a reference slide to help you go find it, and he walks you through exactly what you need to do. In the vSphere environment, there's a great guide. This is a reference slide that you can go that walks you through how to baseline and what the different things mean. And in fact, I've given you some guidelines. If somebody feels I'm a little off, feel free to adjust these. David's looked at them. He thinks they're reasonable also. But that resource management guide ties it all together very nicely. These are baseline suggestions for SQL Server. Once again, this is a reference slide. Go back and look at it later. And some environments are a little unique, and you might want to tweak these. Once again, David's got a great article. And in fact, Andy Galbraith out of Nebraska, he's got a nice write-up, which is the one out of the Nebraska SQL. Andy's a wonderful resource also. And by the way, you can get these guys at SQL Saturdays. They both do a lot of SQL Saturdays. SQL profile counters. So what's really important is you got to understand the IOPS. And actually, the thinking on this has changed quite a bit, and I'll explain that in a few more slides. You want to speed up a Monster VM, you minimize I/O, right? They wanted to get the biggest, baddest Monster VM, they put it on flash storage. And in fact, if you're on the Oracle side, I recommend something called SLOB, Silly Little Oracle Benchmarking. Kevin Clausen is a wonderful resource that's available on Twitter. He'll respond to questions, and he makes SLOB available to anybody. On the Microsoft side, there's a new tool called DiskSpeed Utility. As always, David's created a PowerShell script to help. I hate when I mix my words. David's created a PowerShell script to help automate disk testing. It's very useful. I'm not saying it's the end all, but it's free and it can really help you understand things, and they're getting better about dealing with flash storage. Though Arginus, who's may argue with me a little bit on this, but it's certainly a free resource out there that you can use, and there's a nice write-up to get some additional information. So one of the ways that you're going to fail is if you don't communicate. And DBAs, especially on the Oracle side, that are in the physical world, are used to having dedicated machines that are all their own and doing what they want. And then they get thrown into a shared resource environment, which virtualization is by definition. And so you've got to learn to communicate what you need. If you want to have a proper recovery strategy, it means you're going to work on the database side, and you got to work on the virtualization side, because no one side has the correct answer. And so the point is, you got to work at these vSphere administrators because they flunked mining. You got to educate them on what you need and why. And a common mistake, and I'm going to tell you, I see this a lot, is you tell them what you need for IOPS, they hand you a new VM. The first thing you should do is check it before you wreck it. Jeff said this, one of my co-authors on the SQL Server book, and I think it really was dead on. Just check to see if they gave you the right amount of IOPS, because a lot of times they ignore you. It's been my experience. They give you a VM with thin provisioning, and it's been good enough for everybody else because in the world of capacity, that was good enough. A lot of cloud vendors do this. So you have to be really careful with the cloud vendors. They love to do thin provisioning, which to me I'm an absolute not a proponent of, unless you're under certain circumstances, and I actually will talk about that specifically. But in general, just make sure, and if you don't get what you need, go back to them and use it as an education and educate them why you requested what you want. But what you can't do is ask for more than you need to squirrel it away for later, because all you're going to do is hurt your own performance, and all you're going to hurt is the performance of everyone else on the physical box or physical host you're on. We talked about the P2V. I am not a fan, or as Arnold say, I am not a fan. So in the case of the hospital, they P2V 2,500 SQL Server database instances, and what they were doing was they bought way too many licenses, and they were slowing down their own environment because all the VMs were bloated. So I am not a fan to P2V unless you're in a jam. It works, but I would really rather you clean up the environment and right-size them and build from scratch if you can. This is for the Oracle people. You're going to hear from Oracle sales a lot that you're not supported if you run on VMware. It's a bunch of crap. Let me say that officially. It's a bunch of crap. You are supported, and there's a MetaLink note, and certainly you can reach out to me, and there's lots of resources I can hook you up with. So then the question is, how do you configure the virtual world versus the physical world? read the manual. It's the same as the physical world. Your database does not know it's virtualized. Don't tell it. Just treat it like you would the physical world, and you'll be in good shape. Excuse me. Okay. Mr. Klee provided a real-world utilization chart for one of his databases. And what you see is you see all these peaks and valleys. So even your database does not fully utilize everything because of all those peaks and valleys. What that means is that it is a candidate for consolidation. In fact, you'll find this is interesting. At my last company, we did lots of database consolidation exercises. We did so many SQL Server consolidation exercises that we had automated it when actually fixed pricing. And we saw a greater than 50% consolidation ratio whenever we did it. That was the norm. We cut their footprint in half, which reduced. So my point is, you are a candidate, even as a database, for this. There is that rare Monster VM that might hog the host to itself, but that is not the norm. And so you can mix workloads. And the advantage of mixing workloads is your consolidation ratios go up and you save money on licensing. But what you have to be aware of is Monster VMs don't always play well with others. So I go back to that point I made. Tier 2 is built for capacity, not performance. And so when you take a Monster VM or a database and you put it into a Tier 2 environment, I was doing a workshop in Boston 2 years ago. I made this point. One of my customers in the room, a huge organization with offices in 39 countries. And they first tried to virtualize a SQL Server databases. It was a disaster. When they got out of the workshop, they realized they put it into a Tier 2 environment that was never ready for a database, which is a Monster VM by its nature, and so everything misperformed. We worked with them, helped them, and a month later they started virtualizing everything and never looked back. Everything performed just fine. And I love this picture of the Monster VM sitting in the corner. I'm being sent to timeout. I do not play well with the rest of production. I am old school. If you can separate development and test from production, you should absolutely do it. If you can't and you're in a mixed environment, then you need to be comfortable with things like memory reservations, and we will talk about them. Because there are techniques you can use to mix environments. And it will work just fine, but you have to be really careful when you bring in big, complex VMs. So then this old argument, should I have more VMs or more database instances? I believe that every production database should have its own virtual machine. I prefer that because I want to tune at a VM level, I want to vMotion at a VM level, and I want to do memory reservations at a VM level. And so I have this ability to do fine granulation. I did talk to a company that had over 20,000 SQL Server instances, and they said, we just can't do it. I understand. I understand. I'm basically giving you guidelines that work in general for everybody. And so I would argue every production database should have its own virtual machine so that you can tune at a VM level. And by the way, when you have a problem child, the VM jumps out at you. You know exactly where it's happening. Storage. So I used to talk about IOPS. And in the last year or two, my thinking on this has changed, and Mr. Klee's thinking on this has absolutely changed. And our point is, and I think David said it best, David is a car enthusiast, when was the last time you hit 200 miles an hour on your Ferrari? And his point is, how often do you really use the maxed IOPS claims from the vendors? When was the last time you had to go from 0 to 60? And so what we really think it's about latency. Does the storage array you're using have the latency that meets your business requirements? It's not about IOPS. There's an argument if you should use VMFS versus RDMs. If you can, you should use VMFS and future ready your application. There is no performance difference between VMFS and RDMs. Now, if you're using SQL Server failover clusters, you have to use RDMs today, but you can vMotion them. And so it's not an option. You have to use RDMs, but they are candidates for vMotion. But it's not a performance issue. And so I prefer VMFS when I can because it future readies my application for new functions and capabilities. Thin provisioning. I am not a fan of thin provisioning. I want to use eager, thick, zero disk for best performance. By doing that, you avoid the first write penalty. And so for me, from a database performance perspective, I want to avoid that. At a minimum, I want on my database, my logs in temp DB. There are situations where you can get away with thin provisioning, and we're going to talk about those. But as a rule of thumb, I'm not a proponent of it. And it's one of the reasons I want you to read the storage vendor documentation, because sometimes hidden in there is some things that you need to understand about how the I/O is working. So the bigger issue with thin provisioning, in my opinion, is it can lead to oversubscription. You can hand a database log X amount of space. It thinks there's a lot more space there. Then somebody runs a job like that's not going to happen that blows out the transaction logs. And all of a sudden, it can't grow and everything blows up. So you have to be really careful. There's some great blogs. Cormac Hogan has a great blog on this. So I am not a fan because of the oversubscription problem. I don't, with a database, this is a dangerous combination. And for a Monster VM, the first write penalty, let's avoid it. It's okay on flash storage arrays, right? Thin provisioning tastes like normal storage to me on all flash arrays. It's okay to thin provision if you're on an all flash array, and a big if you manage it properly so you don't over provision. So let's drive that point home. Over provisioning is dangerous when it comes to databases. I don't care if it's Oracle, I don't care if it's SQL Server, it's a dangerous practice. Be really careful. And then remember Project Capstone, to drive CPU units up, they had I/O on very fast flash arrays. And in fact, at the SQL workshop, the last couple we did, we put the DBAs in a room and let them beat the crap out of a tin tree storage array and a pure storage array. And what everybody realized was they had a really hard time making these arrays break into a sweat. And so it's really changing the game in terms of the industry when it comes to flash storage and DBAs. The old days of breaking things up by logs, the old days of worrying about what kind of RAID configuration you are going away very quickly. It's not going to be as much of a concern for DBAs in the future. This is some recommendations for SQL Server. Like everything, they're recommendations. Some of them come from SQL Server. I will tell you that newer versions of SQL Server require you to be less conservative. You can read the Microsoft article. You can agree or disagree with them, but the things like RAID are less of a concern on a flash storage array. Para Virtual Driver. I got to speed it up, people. I'm running out of time. This is a biggie. 30% CPU savings, 12% I/O savings. It's a no-brainer. If your system can use Para Virtual Drivers, you should use it. If you're on a SAN, most likely you can use it. It's free. Just put it in for any I/O-intensive workload. Monster VMs love Para Virtual SCSI adapters. And in fact, it's one of those things that you should be using, and it was used in Project Capstone. Absolutely use it. You could have multiple virtual SCSI adapters per VM. Just as it's quicker to drink out of a drink 4 straws than 1 straw, so are 4 virtual SCSI adapters. Now, I'm not telling you to go out and give everything 4 virtual SCSI adapters. What I'm saying is look at your workload, and if you're getting contention, don't be afraid to add more. And in fact, there's a link to a nice knowledge base article, right? Large workloads may require QDEF significantly greater than the default values. You might have to do some tweaking on this. David's a wonderful resource on this. Remember we talked about being a betting person? 80% of your problems happen with the storage array. That's the place to look first. Processor. Let's talk about hyperthreads. Hyperthreading is a real danger because people tend to over-allocate the capabilities of the CPU. And what you realize is it's not 2 chips, it's 1 chip. And it's taking advantage of the flip-flopping or downtime to get you a booster performance. There are workloads where turning off hyperthreading is to your advantage because the workloads are so CPU intensive they're using all the chip. And you can actually get a booster performance by turning it off. For most workloads, you want to leave it on, and you want to give a hyperthread about a 20% uplift. And I'll define what I mean by that. So first thing coming out of the gate, you should never over allocate physical cores to virtual CPUs. You have 32 physical cores, then I would argue you should have 32 virtual CPUs. If you use hyperthreading and you turn it on, if you use hyperthreading and you turn it on, I must have taken out the slide, then you should say that every 5 physical cores that are hyperthreaded, you get a 20% uplift, you get 6 virtual CPUs. So in a hyper-threaded environment, 5 physical cores equals 6 virtual CPUs, and that's a very conservative number coming out of the gate. And that would be a very safe number. Now you can overcommit once you're comfortable. And I want to drive home that point. Some workloads get hurt by hyperthreading that are CPU intensive. This is the max SQL memory settings. About 2 years ago, David and I collaborated and we updated this. And we added from 2 GB to 4 GB for the operating system. The newer operating systems need more. This is a great place to set SQL max memory setting coming out of the gate based on the requirement of the VM. This is in context of the VM size. There's always this question of should you run multiple instances on the same VM? I'm telling you that you should use max server memory. That is always the proper setting. It's not beneficial to use hot add memory when using max server memory. I'm not a proponent of hot add memory because of the NUMA implications. You got to give it rights. In SQL Server, lock pages is a good practice, and we'll talk about that a little bit more. Let's talk about NUMA. This is a no-brainer. It can speed processing according to Mr. Clee greater than 40%, and he does a lot more of this than I'll ever do. IXI is NUMA aware, and it will automatically schedule you on a NUMA node. So let's talk about how you set it. I'm going to give you a hypothetical. You can get this out of the vendor's documentation. Let's say you had a system that was 4 sockets, 6 cores, 4 NUMA nodes, 128 gig of RAM. Each NUMA node is 32 gig of RAM. It's technically under 32 gig of RAM because there's some overhead. So if you want to size this thing 31 gig or less, it will fit in a NUMA node, which is one of those green memory locations. If it doesn't fit, it has to use the cross connects and it's less efficient. So if you want to get optimal performance, the best thing you can do is get it to fit within a NUMA mode, and you can get a 40+% improvement in performance. NUMA thoughts. Couple of things I want to jump out at you. It only gets turned on when you have greater than 8 CPUs. Sometimes you get a benefit if you're in your 4 to 6 CPU. It's got to be enabled up and down the stack. The other thing is that your NUMA locality gets established when you first start the VM. It wakes up and it maps the NUMA topology. If you vMotion that database sitting on a VM to another physical host that does not have the same NUMA topology, bam, performance can go right down the tubes until you reboot the system and allow it to remap. So today, when you first start up the VM, it maps to the NUMA topology, and NUMA is really important. So if you're going to use vMotion and it's not going to an identical host, you better plan for a reboot because who knows how it's going to perform. Swapping, anybody in the database knows that swapping is bad. You have swapping at the host level and you have swapping at the guest level or the VM level. Be aware that you got to be careful where you're looking. Memory compression, ballooning slows you down. That's pretty obvious. Swapping's bad. But there was this advice that you should shut off ballooning. I think that's an absolute mistake. Ballooning kicks in when a physical host is experiencing many memory issues. It's better than swapping. So it's your first line of defense. Leave it alone. Physical resources are hard limits. Keep that in mind. If you have 32 gig, you can only have 32 gig. When you build the VMs, right size everything as possible so that you get the best benefit out of NUMA. Don't over allocate the VM. That's a real danger because it will hurt performance of yourself and it will hurt performance of everyone else. And keep in mind your business cycles, right? Baseline, baseline, baseline. You might make adjustments at certain times a year. Memory reservations are absolutely good. You want to use memory reservations whenever possible for those production systems. If you have 32 gig and you reserve 16 gig for the memory reservation for the database, that means all the other VMs fight over the remaining 16 gig if there's no other memory reservations. But I would argue you should absolutely do this whenever possible. How do you size it? I don't care if it's the Oracle database, I don't care if it's SQL Server. In Oracle's case, it's the SGA, the global area plus the operating system plus overhead. That's a good place to start with the VMs. I love this slide because if you have a memory reservation, what you'll see is that the temp file goes to 0. So in the top, you'll see a swap file of 0. In the bottom, you see that it doesn't have a memory reservation. It gets allocated. So you know you're never going to swap on that production database or that Monster VM if you use memory reservations. Large pages or huge pages do not normally swap. If your system has performance issues, it's got to take those large pages or huge pages, break them down into small pages so they can swap out. I am a proponent of using them when you can, but understand if the system has memory issues, it might ultimately have to break them down to small pages so it can start swapping things out. Obviously, with a memory reservation, that's not going to happen. And this just drives home that physical resources are hard limits. I apologize, people, I'm speeding up because I want to get through all this. So the point is, you should do memory reservations for all the critical systems and understand that once you do that, no one else gets that memory. It's reserved. And if you vMotion, it's got to have the memory reservation available or it won't start. Jumbo frames. I was at a seminar where the storage array vendors were saying don't turn on jumbo frames. I completely disagree with them. The reason they were saying don't turn it on is because if you don't use it correctly, it would crash the storage array. Well, if you don't use anything correctly, it doesn't work right. So jumbo frames are 1,500 bytes. It came about because the old networks couldn't handle anything faster than 1,500 bytes. If your network can support jumbo frames, you should absolutely use it. In the case of SQL Server, you can have a max packet size that's optimal of 8192 out of the 9,000 bytes. And if your system supports it end-to-end, you will get better performance. Some networks claim that if they don't support jumbo frames and there's a constriction point, they will break it down and break it back up. That's absolutely a mistake. Only juice up your network where it can be supported complete end-to-end. And that should be the highest rate that you would ever go. Think of it conceptually. Do I want to move data in 9,000 byte workloads or do I want to move it in 1,500 byte workloads? And this is good for the storage array. So let's put it all together in terms of network. Very basics. If you can separate chatting network loads, then absolutely you should. So for example, having a separate network for vMotion is ideal. If you have faster network cards and some of the adjustments change, and you'll see how in a 10 gigabyte NIC overkill, you'll see a recommendation there. But the thing you should really walk away with is multiple NICs and using the VMX Net3 driver. They used it in the Monster VM. It's really good for virtualized workloads, and so I would highly recommend it. So if you're not using that driver, you should be using that driver. So we actually got to the end of this with about 4 minutes to spare. I want to see if there's any questions. Give me 1 second, folks. At this point, I am done. You've been an awesome audience. And I am publishing my contact information, and the host has agreed to take people's questions, and I'll be happy to respond in writing with them. And so I want to thank everybody that attended this webcam.
Okay, Michael, well, I appreciate you coming on board this morning. At this point, we'll wait here just a moment, but I don't have any questions from anybody at this point. If you'd like to put your questions in there, please do. Um,
And I know it was drinking out of a fire hose, which what isn't easy.
yeah. So anyway, once again, thank you for attending the past virtualization virtual chapter meeting. Uh, Next month, we will actually be talking about disaster recovery in a VM and what one company did to basically go out there and actually handle Hurricane Sandy. So uh, hopefully we'll get that all arranged and up for you because that will be really good. So uh, here's one question for you, Michael. What is the best and efficient way to license SQL on VMware?
You know, I'm not a licensing person, and I really leave that to the licensing people. What I tend to hear is a software assurance is the best way to go about it, but I do not want to pretend to be a licensing person, and I can certainly hook you up with licensing experts who do this for a business.
Yeah, and that's what I hear also. If you have, you have to basically go out and take a calculator to in a spreadsheet and kind of figure out what's the best for you as far as licensing goes and what's going to be most cost effective. In my shop, it would not be cost effective to license the VM host, for example, which you can do.
It's very
That's
common in an Oracle environment to see people have a separate host just to avoid the Oracle licensing issues.
right, right. So on setting the power settings, do you set it at all three levels, host, VMware, and client?
So in terms of the power settings, that's typically just done at the host, right? Because you just want to make sure that the box isn't artificially limiting things. Now, there are certainly lots of settings. In fact, I used to add slides to that effect that can actually throttle the VM if you're not careful. So the short answer is there are settings in vSphere, and there are settings on the VM itself that can affect those things. But coming out of the gate, typically those things are not set. Somebody had to go out of their way to set them.
Okay. Do you recommend jumbo frames at 1500 or 9000?
So Jumbo Frames gives you the capability to go up to 9,000 bytes. I would tell you you should absolutely set it to 9,000 if your network supports it end to end. And this is really important because if there's a constriction point, some router, some network devices says I can only handle 5,000 bytes, and you've set to 9,000, you can have some real problems in performance. So you really want to test it, and there are different ways to test it. I used to show some ping commands that would test the network. But if you can juice it up to 9,000, you should. And in the case of SQL Server, the optimal setting would be 8192. Once again, that magical multiples of eights.
All right. Well, that looks like all the questions that we have today. I will be getting Michael's slides and also putting them up with the recording. The recording will go up in YouTube probably within the next couple of days, and I'll send out an email basically letting you know that it is out there to review. Michael, once again, thank you for taking your time to do this today. I appreciate it. And everyone have a great week. Thank you.